Hi, everyone. I'm Jay Srinivasan from Appurify, and I have my colleague, Manish Lakwani. You want to come up on stage, Manish?
Yeah, sure.
We're the two of three co-founders of Appurify, and today we wanted to talk to you about mobile testing, debugging, and optimization in the cloud. Before we start, wanted to thank Ken Norton for setting this up and giving us the opportunity. You can check out the other talks coming up at Google Venture Startup Labs. I believe you should have also received an email from him with questions with a QA form. So if you have any questions that you want to send over live, we'll be able to see it on the screen here. So the sort of quick background on Appurify and why we're doing this. So Manish, our third co-founder, Pratyush, and I, we met at Zynga a little over a year ago. And essentially the problem that we were trying to solve is addressing the need for mobile optimization, which essentially is something that we saw as an incredibly important thing to do, but there simply weren't good tools out there. And so we decided to start this company around a year ago. Quick background on the team, Manish is our CTO, and he was previously the CTO of QA and mobile at Zynga. Before that, he was at Amazon, led the team that wrote the operating system for the entire Kindle series. Before that, he was at Monte Vista, was actively involved in several versions of Linux, including Linux for ARM processors. And one of the things that we're going to explain is that testing tools are really hard to build. Optimization tools are really hard to build. And you need someone with this type of knowledge of the entire stack to actually address it. I was most recently a revenue product manager in Farmville when I met Manish. And then Pratyush, our third co-founder, was a senior software engineer in Farmville as well. We have a team of 15 right now, mainly engineers, and we're super excited to be doing this. As you can see, we have a bunch of great investors. Again, thanks to Google Ventures. They were part of our seed as well as our Series A, and we're super excited to be talking to all of you today. So, taking a step back, let's talk about the sort of business reason behind us starting this company. It actually comes down to something very simple. How good your app is at launch is, for most purposes, going to dictate how your app is actually going to perform in the real world from a revenue and return on investment perspective. We don't even need to talk about the mobile app market exploding, but there's two interesting aspects to this. One, I'm sure as many of you are aware, it's obviously incredibly hard to actually get discovered in the App Store. So you spend all this time and money building an app, and then you go through this effort of trying to get it discovered. The implication of this is you spend anywhere from $50,000 to $1 million, depending on the size of the company, building an app. Then what you do is you take the majority of your marketing spend and spend it at launch. The idea being you want your app to be as high as possible in the App Store ratings or whatever, with the intent being to get as many organic downloads as possible, inorganic downloads as possible with the marketing spend, with the hope that they'll retain and eventually lead to virality and grow. The challenge here is how well your app is at launch is going to dictate how well it's going to succeed post the marketing spend phase. And very specifically, there's a very strong, on the consumer side, there's a very strong correlation between how many stars your app gets in the App Store and your eventual ROI. Simply put, if you move your app from 2 stars to 4 stars, you're going to increase the revenue that you're going to make off the app by 5x. And so, simply put, it's very that you actually have a good rating for your app. And this is not just a consumer statement. The exact same thing applies to enterprise apps as well. If you're distributing an app, if you spend all this time making an app for the enterprise, you want the app to be adopted and used by the enterprise. And the exact analogy to ratings happens on the enterprise side of the house as well. So the question is, what actually drives bad ratings, and is it addressable? And the good news is, the majority of reasons why apps perform poorly in the App Store are actually controllable reasons. Very specifically, what we did was we went to the iOS App Store, looked at the top 200 free apps, read every single 1-star and 2-star review, and we tried to categorize them into reasons why the reviews were bad. 48% of the reasons were folks didn't like the app, it wasn't something that they found useful, et cetera. These are obviously specific to the type of app you build. However, 52% of the bad reviews were performance-related issues. Specifically, they fall into 3 categories. Number 1, stability and functional bugs. So essentially, your app crashes on load. There's a low memory warning and the app exits. There's something wrong with the UI flow. You click on a button, it doesn't go to the right next page, et cetera. So Stability and functional issues are essentially the first category, and as you can see, they're the majority of they're the majority reason for bad reviews. The second issue is network performance. This is exactly as you'd expect. You're waiting for your app to load. It takes forever on certain networks and at certain signal strengths. Certain pages don't load at all. It's incredibly slow to respond. It's just a very sluggish server-side response. And then the third category is what we call client-side performance. This is you click on a button in your app and it just doesn't respond. It takes forever to respond. Or the phone becomes unresponsive. The phone gets really hot. It's a battery hog. And all of the controllable reasons behind poor reviews essentially fall into these three categories. And simply put, addressing these issues pre-launch, we view it almost as an insurance policy. You've put all this money, blood, sweat, and tears into building this app, and you want to address these issues before you launch it, because if you don't address them, they're going to impact how your app does eventually. And by the way, this isn't just for the first time you launch an app. It's also true for example, iOS 7. So iOS 7, the first developer release came out yesterday. We've all put it on our phones. And I have to say, I think something like 3/4 of the apps that are in the App Store right now crash or have some issue. Some of the most popular apps out there have issues on iOS 7. So it's not just something that has to do with launch. It also has to do with a new device coming out. It has to do with a new operating system coming out. And sort of just to drive this point home, users hate bugs. So here's an example of 2 games that we did an analysis on. The quick context here is both these games are the same genre, cost about the same to build. And the key difference, only difference between these 2 games was how much time was actually spent building versus optimizing, testing, and debugging the games. And as you can see, they both had the same amount of marketing spend in the beginning. So you can see that spike on day 0. Basically, a lot of installs leading to DAU initially. And game 1 essentially petered off, while game 2 sort of stayed flat. And the notion here is essentially stability, performance, and quality is going to translate to ratings and retention. These are going, the retention is going to translate to DAU. The ratings are going to translate to new installs. And at that point, once you have a stable flow, you can actually optimize for revenue. So let's actually understand why these 2 games did the way they did. If you look at game 1, we then went and understood how the game performed on different network conditions. And we found something very interesting. For game 1, on AT&T 3 bars or below, in the first-time user experience of the app, so essentially the first 4 or 5 minutes of using this game, there was a network call that would time out on AT&T 3 bars or below. What would happen is the call would take too long, the iOS watchdog would kill the app. So here's a situation where anyone who downloaded this game for the first time on an AT&T phone who was not on Wi-Fi or did not have 4 bars or above would, within the first few minutes of playing around with this, see a crash. They're not going to come back to the game at this point. So this is a specific performance issue which directly translated to a complete loss of investment in the game itself.
And just let me add something here. This was a synchronous network call. So essentially the app was blocked and it was visible only under specific network conditions. So it was ADT 3 bars and below. And it took us a long time to figure this out, because when we used to manually test it before release, it all used to work perfectly fine. Only after a lot of analysis, we could understand that there was a reason why the synchronous call over TCP wasn't getting the right acknowledgement back and hence timing out. And because it's synchronous call, your main thread is hung, you press the home button, doesn't suspend, and the watchdog kills it.
Exactly. And the point here is, this is actually, if the developer knew this issue before launch, it's actually very easy to address. It's just you actually have to be aware of these issues and actually have to be looking out for these things. So where we're getting is, developers understand the importance, obviously, of a high-performing app before launch. The problem is there is a complete lack of mobile-targeted tools. And specifically, if you try to understand why there's a lack of mobile-targeted tools, there are a few reasons. One, developer tools are just a hard technical problem. And if you just think about the mobile ecosystem's evolution, it's relatively young. It's growing obviously super fast, but it's relatively young. Most of the tools that are out there right now help you build apps faster, but not optimize them. So there's just a natural evolution in tools where they come after the building blocks themselves. However, there's a second issue that's very specific that we're seeing in mobile, where debugging is always hard, but it's actually getting harder for mobile than it was in the web world, than it was in the PC world, because you're now used to using so many third-party SDKs, so much open source code, so many, it's not just your own code anymore. So when you're debugging, you don't even know if it's because of your code, if it's because of somebody else's code, and how you're actually going to go fix that. So that's challenge number one for mobile. But again, very specific to mobile, there's a second issue where now you're not only optimizing your app for in iOS for an iPhone 5 on Wi-Fi with like no memory restrictions, you have to actually validate how your app performs under every real user condition, because the real user conditions are in the hands of real users who are actually going to leave the real reviews. And so you have to think about all the different device types. You have to think about all the different operating system types, iOS 7, for example. You have to think about all the different network conditions. You need to think about what happens to memory, the memory availability on your device. You have to think about your accelerometer, the location of your device, your NFC, whatever hardware, other hardware components you want to test for, because essentially users are actually going to be doing this. And the user with an iPhone 3GS on AT&T 2 bars with 17 apps running in the background and 5% battery life who has a bad experience with your app is the one who's going to leave a review. So you have to actually optimize for these conditions. And what we've seen across the board is, since developers know this and since they understand the impact of this on their ROI, they throw bodies at the problem, right? Right now, there's no good tool, so what you're going to do is spend as much effort as possible manually testing, for the most part, your apps. And we've seen anywhere from 15 to 50% of development spend on an app now is spent in some form of testing and optimization. And by the way, this is only going to get harder and harder as the build systems get better and better, as your coding tools get better and better, and as the pace of release of apps gets faster. You're just not going to be able to keep up with it manually. Let's actually look at the enterprise. It's actually even tougher for enterprises because, as we all know, mobile app developers are among the hardest resources to currently hire. And so what we've seen with the majority of the enterprise customers that we're working with are they essentially outsource app development. So now you have a third party building your app, you have another third party testing your app, and your users are finding issues in the field. And just the communication process between dev, between QA, between the customers is just incredibly cumbersome and slow. And the implication here is this is just for functional testing, et cetera. We're not even talking about security screening, load testing, which are even more complex problems. And so this is sort of the business overview behind why we started Appurify. And we have a very simple mission. We want to create a comprehensive mobile application lifecycle management platform. We don't want to just address testing. We don't want to just address debugging. We want to handle the entire application lifecycle for mobile development. And to that end, what we've built is the first API-accessible, scalable farm of mobile devices with powerful first-of-their-kind testing and debugging tools. The idea here is very simple. We have a real farm of real mobile devices. Think Amazon EC2, except instead of servers, you have mobile devices. You can access this farm through an API. And on top of that, we have a SaaS platform with the full suite of mobile optimization tools. And there were a few guiding principles that we've learned over the last year talking to several customers behind how we've built this. And we're seeing a lot of customers already there. We're seeing a lot of customers trying to get there. But there are a few principles that we're focused on. One, you have to have a solution that's comprehensive across devices, operating systems, and apps. You can't just serve games. You can't just serve video apps. You need to have a solution that actually addresses everything, because otherwise it becomes a niche product. Two, you have to test on real devices under real user conditions. We're huge fans of simulators and emulators when they need to be used. But at the end of the day, your users are on real devices under real user conditions. And that's what you need to test and optimize on. Three, specifically in mobile, much more so than web and PC, this is a developer-first process. So we see the world of QA being a distinct organization from development going away in the mobile world. It's going to be one integrated org which has a very, very tight feedback loop attached to it. So whatever solution that you're going to use for mobile optimization has to be developer focused, and along that front, it needs to be automated and integrated with development CI tools. The idea here is very simple. Manual testing is simply going out the door for mobile. It's not a scalable process. If you're trying to do it right now, we strongly encourage you to think about how you're actually going to move towards automation, because you're not going to be able to keep up with all the manual tests that you need to do. It's just simply not scalable. On top of that, though, ideally, you want to be integrated with your development process. whatever CI system you use for your build step, that step should ideally link into your automation testing as well. And then finally, you don't just want to do testing, you want to be able to actually use the same solution across the board, all the way from build, or at least from initial functional testing, all the way till post-launch optimization. And the implication of this, obviously, is you're able to launch bug-free, stable, high-performing apps, right? And this is not post-launch where your customers are finding the issue. 2, you're going to actually be able to speed up the development process, because I bet you half of your time is not building new things, it's debugging existing things through incredibly cumbersome manual processes. So if you actually do this properly, you're going to be able to speed up your development process, actually launch your apps faster, while saving money on QA as well as development resources. So these are the guiding principles behind what we've built at Appurify. And so just sort of emphasizing that, we can synthesize it into 4 points. 1, you want to automate your testing. And we'll show you how you can automate it with Appurify's API. And the point with automation is you can either use an existing automation framework that you're comfortable with, or we have a super simple, easy to use scriptless framework. 2, we will provide the real devices and real user conditions. It's not a scalable option to actually go buy every single device out there. It's just not worth it. And so the benefit of actually being able to outsource the device farm means you get access to every device, every operating system, without having to go buy everything. Now, obviously, you want to take these devices and also put them under every different user condition, which Appurify can do for you as well. Now, if you're actually doing automation, and if you're actually doing it on every device, every network condition, every operating system, you're going to get inundated with data. And so the data that you get back has to be as actionable as possible to actually fix your mobile issues. And specifically, given what we saw about what drives poor ratings, there are 3 categories which you need to be able to address issues in: crashes, network performance, client-side performance. And automation is awesome, it's going to be great, but at the end of the day, you're still going to have to do some manual debugging. So simply put, how do you do manual debugging as effectively as possible? And to address that, we've also built the most advanced runtime debugging tools for mobile. So I'm going to go through 2 more slides, and then we're just going to move into a demo, which is probably much more interesting than slides anyway. And the platform that we've built has 2 components. There's a SaaS front end and an infrastructure back end. The infrastructure back end, as I said, is essentially, think Amazon EC2, on-demand device, except with mobile devices that are on demand, that are API accessible. So it's a scalable, distributed farm of mobile devices, both iOS and Android. These devices are hosted in our facility. They can be dedicated to you. You can share them across multiple customers. Obviously, different customers won't see each other's data, but you can essentially share the same devices, as a result, saving cost. We also have a solution where if you absolutely need your devices behind your corporate firewall, that's fine. We do on-premise devices as well. We will provide this across multiple colos, so if you need to test on a device in Europe versus Asia versus the US, we can actually handle that. The majority of our devices, in fact, all of our devices now, are non-rooted. And this is actually a fairly important point to make. Rooting and jailbreaking devices has its uses, and we're not saying you should never do that, but there are situations where there will be issues that are introduced by rooting itself. And so it's incredible, and the majority of your customers are not going to be using rooted devices. And so if you have an effective tool, it needs to be able to do everything from an automation perspective on real non-rooted devices. And obviously now, if you have a distributed farm of mobile devices, you need to make sure that they're stable, that they're scalable, that you can monitor them remotely. This is a lot of the tech that Appurify spent its time on over the last 6 months to a year. Simply put, as I said, mobile devices aren't servers, right? They're not meant to be remotely managed, remotely accessible, et cetera. And so a lot of our tech actually goes into maintaining this stable and scalable farm. Now, you can access this farm through our API. And right now, our world starts at the build step. So whatever build system you use, it can be Jenkins, it can even be Xcode on your laptop. Whatever build system you use can directly communicate with the Appurify platform. You can also manually upload your app binaries to the platform. We also have a bunch of partner integrations that I'll show you. The interesting thing about the fact that we only get engaged at the build step is right now we don't want your source code. So we don't want you to have to share your source code, have to worry about that at all. We'll be able to do everything with just your binaries. Once we have the build, the next step is automation. And here's our quick take on automation. Across the we've probably spoken to 500 to 750 mobile development companies in the last year. And I would say 80% of those folks buy into the need for automation, but less than 15% of them actually do any automation right now. And this is, again, very for good reason. It's not easy to write an automation script. You need a dedicated resource half the time writing the script. However, for the folks that do already have some form of automation, we say more power to you, and we'll support that. So any existing iOS or Android automation framework, we're talking about KIF, Calabash, Appium, UI automation, OC Unit for unit test, Cedar for unit tests, Kiwi, Frank, you name it, our platform supports it. So if you already have any automation tests, our platform will run those automation tests on real devices, on Android, Robotium, RoboElectric, Calabash, UI Automator. So your existing library of automation cases aren't going to go anywhere, except instead of running them on a simulator, we'll run them on real devices. However, for the folks that don't have automation right now, we basically offer two solutions. The first solution is essentially what we call Appurify Robot. The way to think about this is it's smarter than a monkey, stupider than a human. It's not going to randomly click on your app, but at the same time, it's not going to know exactly what to do with the app. And so it's a great way to actually stress test your app. What we do is we dynamically create a tree of all the UI paths in your app and recursively start clicking through it. So it's a great way to actually take your app and just have someone plug away at it nonstop. So one solution, if you don't have any automation, is Appurify Robot. However, you still obviously want to do functional automation. And in the situation where you don't have a test case, what we can do is actually get you running on a full suite of test cases by simply interacting with your app. So on the next slide, I'm going to take you through our SDK. But what our SDK does is it allows you to manually interact with your app on your local phone. And we automatically convert that to a UI automation script in iOS and UI Automator for Android. The idea here is we don't want to do an Appurify proprietary framework, because then you have all the same challenges with other frameworks where you're not sure when it's going to get updated for iOS 7. You don't know when it's going to get updated for the next Android SDK. So we wanted to stick to the Apple standard UI automation and Android standard UI Automator. All you have to do is manually interact with your app once on your real device, and that will automatically generate your automation scripts for you.
And let me just add here, it takes care of logging in, and it takes care of going from one screen to another. All these test cases are managed on the device. So essentially, if you want to keep the device untethered, move to another, you got a new build, you post a new build, and now you want to quickly run the same test, you can invoke the SDK to list down all the test cases, you can run it again. So one choice is you constantly keep using the same test case over and over again, and if it turns out to be really useful, you want to use it for CI, you upload it to the cloud, you convert it to a your automation script, and now it runs per build.
And it's actually a fantastic point. So literally, just like a best practice is to write a unit test every time you write some new code. With Appurify automation, every time you put in new functionality into your latest build, the developer can simply play around with that local build on their phone, and you now have a functional test case linked to that latest push. So it's as easy, that's how easy it is to actually create test cases. And again, it's UI automation and UI Automator. Now, once we have your test cases, either your own or either the robot or either Appurify automation, what we then do is we take your latest build and we simultaneously run it across every device, every network condition, every operating system. And I'll take you through what we mean by network condition and other user conditions. But the idea here is we massively parallelize the run so that you're not now waiting. A, you don't have to go source all the phones. But two, as you check in, all these devices are simultaneously testing your app. Now, let's talk about the user conditions that we can actually support. The first thing we do is we can dynamically change the network condition of the device. So what that means is the same device that you're using to test on Wi-Fi can then go to AT&T, Verizon, and Sprint. It can then go through 1-bar, 2-bar, 3-bar conditions on each of these carriers, and the full range on each of these carriers. Take that a step further, you can actually script network profiles. What this would mean is a standard scenario that your users are probably going to go through is entering a building. So they're outside on the street, they're on their phone, they have Verizon 4 bars. They enter a building, the signal goes down to Verizon 2 bars. They get in an elevator, they lose the signal. They come out, it goes back to Verizon 2 bars, and then they switch from 3G to Wi-Fi. That's a network sequence that your users are going to go through. Your app needs to be able to work through that. And so our platform will actually allow you to script network profiles that you can actually test while your functional tests are running. So that's the first thing that we can do. Second thing that we do is we can dynamically restrict the amount of available memory on every device. A lot of apps perform really poorly at low memory conditions, and our devices will automatically adjust the amount of available memory. We can change the location. You can actually give 2 latitudes and longitudes and drive between those 2 locations, and your phone is actually thinking that it's moving between those 2 locations in the middle of a test. So any test that requires GPS functionality, our platform will actually do for you. You can simulate accelerometer events. You can simulate compass events, magnetometer events.
A gyroscope. Yeah.
Gyroscope. Anything that a user will do with the real device, our platform will do on the devices in the farm, except it's API accessible and it's scriptable. So you can have a test case and you can have a test suite that not only tests across every device, but also tests on different network conditions, different memory conditions. All of these completely in parallel. Next, let's talk about the results that you'll actually get. The first thing is, obviously, you want to see if the functional test passed or failed. So whatever format the functional test in, Calabash, it's an HTML file. The OC unit, it's a simple text file. Whatever format that you're going to get for your test result, you're going to get back for every device, for every run. At the same time, you're also going to get a video of what your app did on the device. So this is just to let you know, functionally, did the app work? And if not, where it broke, and be actually able to visualize that. After that, what you're going to see is our results are, we try to get as actionable as possible in our results. And specifically, they're bucketed into these 3 categories of stability, network performance, and client performance. So on stability, what we're going to do is we're going to give you crash reports for whatever device this ran on. And it's not just going to be your symbolicated crash report. What we do is we also give you a special log that we create that's essentially a conglomeration of your syslog, a bunch of network information, a bunch of memory information, a bunch of stuff that was going on the device. And this is a timestamped log that you get in addition to your crash report. The notion here being, sometimes your app crashes, but it's not your app's fault. It's because the device did something. It's because some other app did something. And the log will actually tell you what was going on when the crash occurred. So you're not only looking at a symbolicated crash report, you're looking at a log that helped you focus on exactly what the issues were. So the first thing, as I was saying, you're going to get is these crash reports, so it's going to help you improve stability. The next thing that we're going to do is we're going to give you the PCAP or HAR files, essentially the network waterfall files for every run. So if your phone was on, if the automation was running on an AT&T 3-bar device on an iPhone 5, you're going to get the network waterfall for all the network activity for your app. Now the advantage, and this is obviously done for every single run, for every configuration that it was run on. The advantage of this, obviously, is you can immediately figure out what your network bottlenecks are. What are the calls that took the most time? How do you actually, and so you're actually able to go look at those calls and figure out which ones you want to compress and make faster. This is going to immediately improve the network performance of your device. The other thing that we do, though, is we've recompiled the Google PageSpeed tool to help with mobile optimization, not just for mobile web pages, but for native apps, for hybrid apps, for HTML5 apps. So what we'll do is we'll automatically pass your network data through the Google PageSpeed optimizer, which has been Google PageSpeed, which has been optimized for mobile, and we'll give you very specific information on what you need to compress, what you need to cache, what cookies you need to increase the expiry on, what you need to minify. It's super targeted information that will immediately tell you how you can speed up your network performance. So just like your crash report's going to tell you exactly what's causing the crash, we're going to tell you exactly what's causing your app to be slow from a network side. The third thing we're going to do is we're going to give you CPU data, memory data, network data usage, battery consumption, and temperature information for each of these runs over time. Two things that you're going to be able to do with this. One, you can obviously see how your app is performing, make sure that consecutive builds are using less CPU, using less memory, it's not consuming too much battery. However, we also have a massive database of something like 1,000 apps against which you can very quickly benchmark how your app performs. So you immediately know not only is your app doing better than its previous builds, how your app compares to all your competitors. And this is not data that we've gathered from the competitors. We've actually gathered all this from the App Store. So it immediately allows you to benchmark how your app does. Now, once you've benchmarked it, how do you actually improve it? You need that information to be as actionable as possible. And so what we do is, behind the CPU data, behind the memory data, et cetera, we'll give you, in the case of iOS, we'll literally give you Xcode instruments traces with whatever template that you want. So all of your memory leaks, which CPU functions, which functions took up too much CPU usage, all your frames per second information. What else, Manish, would you add in the instruments traces?
In the instruments traces, I mean, if we have custom templates for memory, for CPU, or we can club all into one. If you have a developer version of the build which goes through all these automation sequences, then for every run we'll be collecting your leaks information, your allocations, and your time profilers. Additionally, we also have frameworks built in to tell you how much time it takes to interact with the app on load. So basically the load time, the time to interact, the time to flip through pages, time for loading views, unloading views, for app to come back from background, go back to suspend. So all these things, a cold start, warm start, everything's available. So essentially from a performance standpoint, we divide performance into three parts. One is client side, which we take care of, the server side through the server side calls, and it's the internal app mechanics which is done through instruments, a performance optimization.
We can also do frames per second. We can. Right. So what's our OpenGL support situation?
So if you use the SDK, and even if the device is untethered, and while you're playing with the game, you can actually start an FPS calculator, and it tells you what the FPS is while you're interacting with the game, or even on a UI which is showing animations. And of course, if you run the UI automation test suite or any test suite that you have, we can even collect OpenGL traces which can be fed into instruments.
So all this to allow you, as part of this automation, to get as actionable information as possible so that you can figure out what you want to focus on and what you want to actually improve. But at the end of the day, you're still going to need to do some manual debugging. And so for that, what we've essentially enabled is, for the first time at runtime, Chrome developer tools for native, hybrid, and HTML5 apps, as well as mobile web pages on real devices. So we'll show you a demo of this, but anything that you can do with the mobile web page with Chrome developer tools on your Mac or on your PC, you're now going to be able to do at runtime on a real device for your app. So it's basically an incredibly powerful way to quickly start debugging issues in your app as well. One more slide, and then we'll go into the demo. Let's talk about the SDK itself that we offer. So what we're providing is, so taking a step back, if you're in a situation where you already have your automation frameworks written, you don't need Appurify's SDK at all. Essentially, you can plug straight into our platform, choose your devices, run your apps, get all your results. However, in the situation where you need to create UI automation or UI automator test cases using Appurify automation, what you do is use our relatively small SDK, which we can even break up into mini SDKs. And it's a simple process to integrate it into your build. It can just be your debug build. You don't have to launch with it. And it basically provides 4 functionalities. One, that SDK will allow you to create Appurify automation translating with script generator, which will actually allow you to create automation test cases. And as part of this, you're also getting the live view and the video capture of the manual interaction with the app. By the way, the cool thing about this is you can actually, in theory, one of the things we're going to, it's not out right now, but it's going to be out soon, is you can actually distribute the SDK in your production app, and your customers interacting with your app, you can grab and auto-generate UI automation test cases. So in other words, you're actually crowdsourcing your test automation to your customers. And obviously, the tests that you want to run are what your customers are actually doing with the app. So that's what that part of the SDK enables. The next thing is the runtime debugger. As I said, Chrome developer tools at runtime for your for native hybrid HTML5 apps. The same SDK allows you to do that. It also allows you to do crash reporting. So right now, obviously, I'm assuming most of you use one of several very popular post-launch crash reporting tools, like all originating from PL Crash Reporter, like Hockey App, Test Flight, Criticism, Crashlytics, et cetera. The same post-launch functionality from a crash reporting perspective you'll get. However, more importantly, pre-launch, you're going to get all the crashes. We can also automatically file your tickets into Jira. And then finally, you can also gather all your client-side performance information, CPU usage, memory usage, et cetera, with the SDK. So with that, let's actually move straight into a demo.
You want to show the API documentation before, since we spoke about the API?
OK, so let's actually talk about how the API flow works with with Appurify. And we can actually open up the document to quickly show you how it works. Essentially, your API call will, as part of your API call, you'll dictate the number of devices and user conditions that you want to run that particular build on, as well as the number of iterations. One of the interesting things about this is we have some customers that will take the same automation test case and run it continuously over the weekend. And the idea is over the course of 1,000, 2,000 runs, they're going to get 4 or 5 crashes. These are intermittent crashes that you're never going to be able to recreate on your own, but your customers are going to be able to see. So that's the advantage of constantly running this. But what you do is you dictate the number of devices and user conditions desired for the run. Once the API request is done, we automatically reserve the requested devices for the user session. We configure those devices under the appropriate user conditions, network, memory, location, etc. Then what we do is automatically take the provisioned version of the app, install it on the device, launch the tests, and in parallel across all of these devices. And as I said, these tests can be existing automation frameworks, Appurify Automation, or Appurify Robot. Once the tests run, we capture the device statistics, the app statistics, the crashes, the network data, et cetera. Grab all of that. The test finishes, or it crashes, exits early, whatever. We'll grab all this information, put it on our dashboard, host it on S3, automatically uninstall your app, clear all the caches, everything on the device, and release it, remove the provisioning, and release it back into the pool. So we completely handle the usage of the device, privacy issues, all of that's completely managed by our API. And then obviously, we can file these tickets directly into Jira if you want. If not, you can just grab them from our dash. The device is freed for other use, and it's reset to the original condition.
You should show the doc as well, yeah.
Yeah, let me just quickly open up our... Okay, so you want to go through this?
So the API is divided in 2 parts. One is the API that allows you to send the IPA over at a platform level. And the second set of APIs let you make changes while your scripts run in parallel or inside your scripts. So for example, let's take an example of setting the location. So all of these APIs can be accessible from any of these test frameworks. You can call them from the test framework. You can start them in parallel. Let's say you want to change the location every few seconds, you can start doing that. You can even set it before the entire test run. Everything's doable. Location, for example, very critical piece. You can give us a lat long, we can set it, or you can even go into specifics, for example, the altitude, the accuracy, the speed, in order to simulate driving. Next is orientation, of course, and following that is network conditions. So of course, with the network conditions, you can tell us which carrier, the signal strength, and we'll be able to create and put the device, create such a template, put the device in that condition and run your test. Multi-touch, we support all gestures, any number of touches, any number of fingers and taps, swipes, pinch, zoom, rotate. And then going further down, there is of course rotation, and then there is device memory, as Jay mentioned before. We spawn a bunch of background apps which take the device memory down, and that's how we control the device memory. And other than that, we have a bunch of other things that you can randomly invoke in between your tests, so you know you're actually mimicking user conditions. And then this is of course the platform specific API. Once you register, you get your API key and your API secret, and then this API can be plugged into Jenkins as a post-build step, and then all you need to do is pass us the IPA. We completely help you set up Jenkins as well for iOS, Android, and from that point on, every time you check in, you can create triggers based on this. We are convinced Team City, Perforce, Rational, both at an enterprise and a developer level. It's completely configurable. Yeah, so this is API. We are constantly adding support for newer I/O. Like for example, this doesn't contain documentation on gyroscope, magnetometer, compass, accelerometer, but if you need data, we can provide you.
The one other thing that we add is we're the only folks that can actually automate across apps.
Yeah, that's important.
Let's say you have a bunch of our initial customers have apps that interact with the preferences app on
Facebook,
or the Facebook app, or Twitter, or whatever. We can actually help you create automation test cases that load your app, switch to the other app, switch back to your app. Right. All of this completely done. Completely automated. So that's also something that
right. So one of the things is many apps require Facebook or Twitter to log in, and when you do that, you lose the app context and you can't go back to the app since it's a non-rooted device and so on. So what we do is we have created libraries. We do some customization based on your app requirement. So it's a one-time thing. Once it's done, it constantly runs.
So we're going to run through a quick demo right now. We're going to show you manual access to our platform, but this is purely for demo purposes. The notion here is everything that I'm going to show you now will actually happen through through the API. Oh, and we also started receiving some questions, so we'll address that as soon as the demo is done.
Yeah, let's do that. Yeah.
So for example, on iOS, we support everything from the iPhone 3GS till the iPhone 5, iPod 5, iPad Mini. Right now, it's up till iOS 6.1.3. Right. We also have, and as soon as we're allowed to share iOS 7, we'll do that as well. What I'm going to do is load one of these devices, and again, the interaction I'm showing with you is manual, so we have an interface where we can actually stream the video off the device to show you. So this is a real device in our offices in San Francisco. And the first thing I always do is open up the camera. So that's the roof of one of the meatpacking buildings across the street from the Caltrain station in San Francisco. It gets really hot, air conditioning isn't there, et cetera. But that is the roof of our office that you're actually seeing streaming over right now. So this is a real device in our office. The first thing is to the point around the conditions that we support. So right now you can manually switch to any network in any carrier, but the way, again, the notion here is across the API you're actually able to do this. Similarly, you can. We have a simple Google Maps interface right now where you can set your location, but you can do that, and this is where our office is located. But you can also, again, pass this through the API. You can change the amount of available memory on the device. You can rotate the device. Now, let me actually start showing you some of the data that's collected. So I'm going to open up Safari. Well, let's actually first start recording here. See what's going on on CNN today. Okay, so real device in our office. We're loading up CNN. Everyone's talking about the NSA thing. Now, if I go here, the first thing that you should be able to visualize is all of the network traffic. We're, again, showing you the manual interface here. Now, think about this just continuously running, and you're getting it for every device, network condition, et cetera. So this is obviously just the visualization of all your network calls, and we do this for HTTP as well as HTTPS. You're able to get all of this information. Immediately, you can start looking at what your bottlenecks are, how you actually want to optimize that. In addition, though, we automatically run this through paid speed. And so basically, this file that you're going to get along with every build, which will present in a much prettier format. And in fact, to show you how that would look, we're using this tool. So what you're basically going to get is a score. You're literally going to get a network score for every run on every device. And it's going to tell you specifically, in addition to the waterfall, it's going to tell you specifically what you did well, what you didn't. The closer to 100 you are, the better. And for the stuff where you're not doing a good job, you're basically going to be able to click here, and it'll give you incredibly specific information on things that you can do to immediately speed up your network performance. So on the network side, this is what we'll be able to do, except obviously for every run out there, right? Next thing is, again, so this is the CPU usage, memory usage for the run that we're just doing, all this for Safari, app memory usage, free memory on the device, network traffic. This device is actually plugged in, as you can see, this device is currently charging. However, we have devices that are not charging as well when you access them. And in those situations, you'll see numbers in the battery category as well as the temperature category. One of the things you can literally do is load up 2 of our devices, let it run for 2 hours with whatever test you want, one device with that, one device without, and you can immediately track what your battery consumption is. Take that a step further, we can actually give you the current profiles from the battery. You can look at the app CPU usage, you can look at the video of what was going on in the app and actually detect what's driving poor battery consumption on your app.
Additionally, one of the things we want to add here is the damage to the consumption of the radio by the app. So what happens is if you have bursty traffic, you wouldn't be letting your radio of the phone go into a low power mode. So it will be constantly waking up and it will be consuming battery. So we will be very soon telling you the kind of data you're requesting and how much wake-ups of the radio you're doing. So how much can be optimized so that you don't need to constantly wake up the radio.
Okay, so now we're going to show you the debugger. And Manish, you want to drive this?
Right, yeah.
You can just do it off my thing. So what we have here, again, I want to emphasize, this is the manual interaction over the cloud, the video quality, et cetera, as a function of that. You'll be able to do everything that Manish shows you with the app in your real device, with your personal iPhone or Android device plugged into your local Mac.
Right, so this is your Chrome DevTools against an app that is running on a real device. So this is your HTML5 app.
And by the way, this is the Apple App Store app that we opened, that comes with every device that we're doing this on. So imagine this happening with any app that you have with the SDK.
Hold on, so do I need to close this?
Oh, you want to reopen it?
Yeah, I want to reopen it. So
okay, so you can just click that again.
Yeah, okay. Right, so this is Chrome DevTools. It will start inspecting. It'll start inspecting the app. Give me a sec. Yeah. So there you go. So it has started inspecting the app. So I can drill deeper into the divs, and as you can see, I'm actually inspecting the top half right now, and the entire layout. And then what's going to happen is, if we go here, we can actually start doing the timelines, right? And the network, of course. And then you can see some of the network calls being done, how much time it's taking. And this is your entire render. So this is your standard Chrome DevTools, but it's against a real app on a real device. And this is basically telling you the amount of time it takes to render the JavaScript events, your network calls, and to the depth of your heap size. So how much of the heap size you're consuming. So this is the depth of debugging that you can get for an HTML5. We'll show the native as well. Similarly, you can get your profile, so you can start profiling the apps, and you can get details about which JavaScript calls are consuming CPU, so you can optimize. Any HTML5 app or hybrid or mobile web, this completely works. For example, I can go to the console. And as you can see, this comes up here. So I'm actually able to interact with the app through the debugger. So this is the HTML5 side. We should start the native.
Yeah, let me close this and open that up.
Yeah.
And again, guys, the point here is this is something that you'll be able to do with the device in your hand.
Yeah, using the SDK. This is completely in your control then.
Exactly. So let's open up Facebook. So again, we're taking the Facebook app in the App Store. This is the Appurify native debugger interface.
So what's happening here is, as you can see, I'm actually viewing the layout for the Facebook app, and I'm looking at the entire view hierarchy. Along the same lines, we also got the network. So for example, if I go here.
Actually, the thing is, it's not a Facebook call.
Oh, okay. So I have to go back, right? One sec. Yeah, let's say. Okay, so this should be able to. I have to start again, maybe, right?
Yeah, so I think you can click refresh.
Oh,
but anyway,
sorry,
you get the runtime network information, you get the entire UI hierarchy, and then you get a console.
Right. Should I start here? Yeah, let me do that. Right, so this is where the network is. Yeah, and then
Quick sign up.
I don't know if it makes the network call at this point. I think it has to.
Well, anyway, the point here being it's runtime runtime element console as well as the runtime network console, and then the runtime network interface.
Let me actually delete a specific view. So as you can see, that's the help center. So I'm gonna go and delete the node, and the help center is gone from there. So essentially, You can start editing your views at runtime. You can make changes to the text. We also have a console. I don't know if it works here, but it works in your hand. Yeah, I can't type here, but it works with the SDK in your hand. My phone's running the SDK. I can show you a demo on my local laptop as well. So this is the native debugger.
Exactly. And what we're going to do is actually distribute this SDK. So we're going to basically provide the opportunity to do runtime native as well as HTML5 debugging on a device in your hand. The SDK should be ready by end of July is what we're targeting, at which point we'll start distributing it. We're still in a closed beta, but that's something that we'll be doing soon. The one other sort of quick thing that I wanted to show before going back to those other slides was, here's the thing. So we actually have all this information on a bunch of different apps. So for example, let's say you have a game that you want to understand how your game compares to everybody else. We can actually tell you what your average load time is compared to everybody else. And again, obviously we'll never share customer data. This is stuff that we've collected off App Store apps on our devices. Similarly, we can tell you how your peak CPU usage compares to everybody else. We can tell you average CPU usage, memory, average memory. And by the way, this is an average snapshot, but we can actually give this to you over time. You can understand what the profile of your app looks like versus other folks' apps, et cetera. So the idea is we want everyone to be able to build an app that's not only competitive, but also optimized. Or not only optimized, but also competitive. So going back to the slides, and then we're almost out of time, and we want to quickly get to those questions as well. So, this is just a list of the frameworks that we support. Here's the simple summary. If you don't see a framework on this that you're using for automation right now, let us know. We'll add support to it. These are just the ones that folks we're working with right now use. The way the platform has been designed, we are almost completely agnostic to any existing automation framework out there. So if you have your own personal favorite, please let us know. We'll get that running on our platform as well. One or two quick examples of customer use cases that you could only solve with the Appurify platform. On the top left here, this is a runtime snapshot of the checkout function on a retail app. If you think about it, the checkout function is probably the most money-critical part of a retail app. And what was happening was it took 42 seconds for this network call, native checkout.js, to happen. We were able to actually profile this, figure out that it was this call that was causing the issue, and they were able to address it. So this is a little example of using our debugger, quickly figuring out what parts of your platform are the slowest and fixing them, especially if they're money critical. Similarly, we saw a lot of folks having issues when iOS 6 first came out and people had to shift from Google Maps to Apple Maps. There were a lot of shared files that you needed to release a lock on properly, otherwise your app would get killed. Our platform immediately caught those issues for you. Similarly, we can do security screening. You can actually check to make sure that you're passing all the information you're passing over the wire and your writing to disk is encrypted. We can actually give you all that data. And then the fourth example is a battery and network performance analysis. Before we ended, we just want to show you what the farm looks like. In June of 2012, it was 8 devices, and this is the same room from which we showed you the camera. But in June of 2012, it was like something like 12 devices connected to one server. From then to December, we basically got into this complete sort of rat's nest of cables and devices, which part of our farm still looks like this. But the cool thing is we now have the world's first 1U colo-rackable distributed farm of mobile devices. So what you see here is a 1U rack that fits into any rack in any normal colo. And as you can see here, this is actually how it fits in. What you see here are 5 iOS devices and 5 iPhones and 2 iPads. But what we've actually done is stacked them. So there are popsicle sticks separating the different layers. So there's actually 10 iPhones, 4 iPad minis, the Mac minis that drive it, the routers that handle all of this. And then the equivalent for Android is we just take out the Mac minis, we drive them off, we fill up the rack with devices. But just wanted to show you that these are actually real devices in a real colo. So with that, if you'd like to join Appurify's private beta, please send Manish and or me a note. You can also send a note to info@appurify.com. We are currently what we're calling a closed beta, which basically means we're adding customers one by one. We're in the process of getting to a stage where we'll be able to add a lot more folks very quickly, and we hope to be there by end of July. I want to just quickly answer the 2 questions that we see up there. One, can you share more details on your business model? I understand you may not have settled on a pricing structure, but if you can speak in high-level terms, that would be much appreciated. The quick context here is everything that we do is pegged to time on our devices. We don't want to charge for the SDK separately. We don't want to charge for our automation separately. If you spend time using our real devices in the farm, that's the only thing that you need to pay for. The way it works right now is at a high level, if you want dedicated devices that you're using 24/7, which we strongly encourage because you're going to catch intermittent issues, in that case, anywhere between $175 and $250 a month per device. Way to think about this is you're spending less than $5 a day for a fully dedicated device that's capturing all this data for you. If you want to use our devices by the hour, that's fine as well, at which point it ranges anywhere from $4 to $6 an hour. And so if you guys have any specific questions on that, we'll soon publish these numbers on our webpage, but if you have any questions in the interim on pricing, please send us a note. The second question is, will I be able to set up the device environment I need to run my test on? For example, if my test case needs a Facebook account or images in a photo album. Absolutely.
Right. So if you ask us to populate the camera, we will be able to create images in the, we'll be able to capture images and put it in the photo folder. And if you want to use a specific account, you can use your Facebook account. After your test finish, your Facebook account will be logged out. So essentially, we don't store the username password. If you want us to create an account, we can do so as well. We do so for many customers. It's testing2@appurify.com. A lot of developer apps use that to log in. So we can do that as well. Yeah.
And by the way, we actually love these types of use cases because it helps us standardize the offering on our end. So for example, with one of our customers right now, they need to scan barcodes. And so we have a rig where we have an iPad that's constantly cycling through barcodes, which can be separately controlled in parallel to your test run, and the camera of the devices is facing the iPad with the barcode. So we can do that.
Bump.
There are situations where if you want to bump your phones together, or if you want to have one phone drive while the other doesn't, all of those types of situations we can handle. And the key is we're able to add all this to the API, and so we sort of encourage these types of cases because we get to generalize our API further. So I think that's all we had. Any other questions? Otherwise, I think we can wrap this up. All right. Well, thanks so much for your time. And at that point, once you have a stable flow, you can actually optimize for revenue. So let's actually understand why these two games did the way they did. If you look at game one, we then went and understood how the game performed on different network conditions. And we found something very interesting. For game one, on AT&T 3 bars or below, in the first-time user experience of the app, so essentially the first 4 or 5 minutes of using this game, there was a network call that would time out on AT&T 3 bars or below. What would happen is the call would take too long, the iOS watchdog would kill the app. So here's a situation where anyone who downloaded this game for the first time on an AT&T phone who was not on Wi-Fi or did not have 4 bars or above would, within the first few minutes of playing around with this, see a crash. They're not going to come back to the game at this point. So this is a specific performance issue which directly translated to a complete loss of investment in the game itself.
And just let me add something here. This was a synchronous network call. So essentially, the app was blocked, and it was visible only under specific network conditions. So it was ADT 3 bars and below. And it took us a long time to figure this out because when we used to manually test it before release, it all used to work perfectly fine. Only after a lot of analysis, we could understand that there was a reason why the synchronous call over TCP wasn't getting the right acknowledgement back and hence timing out. And because it's synchronous call, your main thread is hung. You press the home button, doesn't suspend, and the watchdog kills it.
Exactly. And the point here is this is actually, if the developer knew this issue before launch, it's actually very easy to address. It's just you actually have to be aware of these issues and actually have to be looking out for these things. So where we're getting is developers understand the importance of Hi, everyone. I'm Jay Srinivasan from Appurify, and I have my colleague, Manish Lakwani. You want to come up on stage, Manish?
Yeah, sure.
We're the two of three co-founders of Appurify, and today we wanted to talk to you about mobile testing, debugging, and optimization in the cloud. Before we start, wanted to thank Ken Norton for setting this up and giving us the opportunity. You can check out the other talks coming up at Google Venture Startup Labs. I believe you should have also received an email from him with questions with a QA form. So if you have any questions that you want to send over live, we'll be able to see it on the screen here. So the sort of quick background on Appurify and why we're doing this. So Manish, our third co-founder, Pratyush, and I, we met at Zynga a little over a year ago. And essentially the problem that we were trying to solve is addressing the need for mobile optimization, which essentially is something that we saw as an incredibly important thing to do, but there simply weren't good tools out there. And so we decided to start this company around a year ago. Quick background on the team, Manish is our CTO, and he was previously the CTO of QA and mobile at Zynga. Before that, he was at Amazon, led the team that wrote the operating system for the entire Kindle series. Before that, he was at Monte Vista, was actively involved in several versions of Linux, including Linux for ARM processors. And one of the things that we're going to explain is that testing tools are really hard to build. Optimization tools are really hard to build. And you need someone with this type of knowledge of the entire stack to actually address it. I was most recently a revenue product manager in Farmville when I met Manish. And then Pratyush, our third co-founder, was a senior software engineer in Farmville as well. We have a team of 15 right now, mainly engineers, and we're super excited to be doing this. As you can see, we have a bunch of great investors. Again, thanks to Google Ventures. They were part of our seed as well as our Series A, and we're super excited to be talking to all of you today. So, taking a step back, let's talk about the sort of business reason behind us starting this company. It actually comes down to something very simple. How good your app is at launch is, for most purposes, going to dictate how your app is actually going to perform in the real world from a revenue and return on investment perspective. We don't even need to talk about the mobile app market exploding, but there's two interesting aspects to this. One, I'm sure as many of you are aware, it's obviously incredibly hard to actually get discovered in the App Store. So you spend all this time and money building an app, and then you go through this effort of trying to get it discovered. The implication of this is you spend anywhere from $50,000 to $1 million, depending on the size of the company, building an app. Then what you do is you take the majority of your marketing spend and spend it at launch. The idea being you want your app to be as high as possible in the App Store ratings or whatever, with the intent being to get as many organic downloads as possible, inorganic downloads as possible with the marketing spend, with the hope that they'll retain and eventually lead to virality and grow. The challenge here is how well your app is at launch is going to dictate how well it's going to succeed post the marketing spend phase. And very specifically, there's a very strong, on the consumer side, there's a very strong correlation between how many stars your app gets in the App Store and your eventual ROI. Simply put, if you move your app from 2 stars to 4 stars, you're going to increase the revenue that you're going to make off the app by 5x. And so, simply put, it's very that you actually have a good rating for your app. And this is not just a consumer statement. The exact same thing applies to enterprise apps as well. If you're distributing an app, if you spend all this time making an app for the enterprise, you want the app to be adopted and used by the enterprise. And the exact analogy to ratings happens on the enterprise side of the house as well. So the question is, what actually drives bad ratings, and is it addressable? And the good news is, the majority of reasons why apps perform poorly in the App Store are actually controllable reasons. Very specifically, what we did was we went to the iOS App Store, looked at the top 200 free apps, read every single 1-star and 2-star review, and we tried to categorize them into reasons why the reviews were bad. 48% of the reasons were folks didn't like the app, it wasn't something that they found useful, et cetera. These are obviously specific to the type of app you build. However, 52% of the bad reviews were performance-related issues. Specifically, they fall into 3 categories. Number 1, stability and functional bugs. So essentially, your app crashes on load. There's a low memory warning and the app exits. There's something wrong with the UI flow. You click on a button, it doesn't go to the right next page, et cetera. So stability and functional issues are essentially the first category, and as you can see, they're the majority reason for bad reviews. The second issue is network performance. This is exactly as you'd expect. You know, you're waiting for your app to load. It takes forever on certain networks and at certain signal strengths. Certain pages don't load at all. It's incredibly slow to respond. It's just a very sluggish server-side response. And then the third category is what we call client-side performance. This is you click on a button in your app and it just doesn't respond. It takes forever to respond. Or The phone becomes unresponsive. The phone gets really hot. It's a battery hog. And all of the controllable reasons behind poor reviews essentially fall into these 3 categories. And simply put, addressing these issues pre-launch, we view it almost as an insurance policy. You've put all this money, blood, sweat, and tears into building this app, and you want to address these issues before you launch it, because if you don't address them, they're going to impact how your app does eventually. And by the way, this isn't just for the first time you launch an app. It's also true for example, iOS 7. So iOS 7, the first developer release came out yesterday. We've all put it on our phones. And I have to say, I think something like 3/4 of the apps that are in the App Store right now crash or have some issue. Some of the most popular apps out there have issues on iOS 7. So it's not just something that has to do with launch. It also has to do with a new device coming out. It has to do with a new operating system coming out. And sort of just to drive this point home, users hate bugs. So here's an example of 2 games that we did an analysis on. The quick context here is both these games are the same genre, cost about the same to build. And the key difference, only difference between these 2 games was how much time was actually spent building versus optimizing, testing, and debugging the games. And as you can see, they both had the same amount of marketing spend in the beginning. So you can see that spike on day 0. Basically, a lot of installs leading to DAU initially. And game 1 essentially petered off, while game 2 sort of stayed flat. And the notion here is essentially stability, performance, and quality is going to translate to ratings and retention. These are the retention is going to translate to DAU. The ratings are going to translate to new installs.